This is Hallicrafters Rehabs. Welcome back. I'm in the process of putting things back on the top here. The first thing I tackled was this crystal box. Fits on here right here. I'm not plugging it in. There's a 6B6 right here, and the crystal goes here, and there's an adjust. I did have to go through it, and there was one capacitor that was one of these green type .01 ceramic capacitors, was leaky. So it was challenging to get into there. What you have to do is heat this up and use the desoldering tool to remove the solder, and you have to remove every last trace of the solder. Then it will come out, and then you can get in there. I did replace this resistor because it was 110,000. My thoughts are, if a resistor is right at the top end of its tolerance, even if it went up to 150,000, it would make that much difference with the crystal. But still, I just want to go ahead and replace it since I have it all apart. This mica was fine and everything, and this other one was fine, so the other resistors were fine too. So I'll reassemble that, and I'm not going to do it later, okay? And then it goes back on top. So I'm going to tackle next this. It's really part of the 50.5 kilohertz IF, second IF amplifier and notch filter control box. Basically, the 50.5 kilohertz IF begins with the mixer and IF the mixer and then the oscillator circuit right here, and then you have the other half of it is essentially right here. So this will be the first time anybody, I don't know, maybe somebody, I see the screws do not match, so somebody's been in here before. So let's take a look inside. I've been in the other one and recapped it, the one that's operating. And I discovered Mark 1, okay? I discovered that the recap kit that I bought was for Mark 2, and I did not know the difference. So I didn't have a cap for that, but they sent me an extra one for that back then. And this is welded. Oh, there's no remove. It's maybe not welded, but it's so hardly fastened. Okay, so here we go. And there's a bumblebee in there, which we'll replace. We'll actually go through and check these resistors for tolerance. You have a 6BA6 second amplifier, IF amplifier tube. You have an adjust here, which is really to think about how that works, honestly. But then this control changes the frequency. It's actually I forget how that works, but I don't actually use it that much, and I probably have not done a good job of aligning it in the past either. You really can't see inside there very well from that angle, but there, we tip it up and you see this. There's a couple resistors in here we'll check out, and these, and go through it clean this switch. I'm sure it's fine, and this adjust also. And then this will be ready to go. So that's my next task here. So what we're going to do here is we're just going to desolder some strategic places just to permit the ability to check out capacitors and potentiometers and things. By the way, this is called Knotch Adjust. This is the notch depth, and this is the notch frequency. I did look that up. Now, so we'll just desolder right here. Yes, and if I had a third hand, I would add solder to remove the solder, but I only have 2 hands. This is actually a new solder gun, and it's working really nice. Desoldering gun, I should say. Alright, there's that one. Let's see. Let me get in here without burning resistors. So we'll move this over this way. Yes, it does move. Okay. We're gonna So we're just going to clean the solder out of this one and check these 2 large size capacitors. And that one is attached right here, so we'll desolder here. We're going to have to take it out anyway. It's a bumblebee. And we don't like bumblebees in our radios, do we? Don't you love that singing? It's got a lot of suction going on in there. Okay, that's really not gonna, it's gonna have to come around on the other side a little bit. Okay, and I want to also detach these potentiometers just to check them out. This one has just a jumper, a little hard to get to. Let's see, do I want to just pull it out? Probably not. We can do this and that. The wires look in good condition. I probably won't do anything with them. Unless I have to. Okay, that'll permit me to remove that jumper. And the resistors, the rest of the resistors can be checked. Oh, we gotta remove this one too. Check this capacitor. The resistors can be checked in circuit, but you can't do capacitors. It just keeps on flowing that electricity. Okie doke. So I'll work on this a little bit and then we'll do some checking. Okay, so I got everybody ready for testing. It's funny. When you I found this capacitor had been clipped too short, so even the manufacturers make mistakes sometimes. It's okay, it won't be a problem, but it's kind of funny that was found that way. So we'll start with this one. It's a mica. Let's see, can you see the... Okay. I can't tell whether the camera can see this or not. It can't. Alright, let's try this again. So we're testing for leakage. And there's absolutely none. I didn't expect any. These have really good service. Okay, we'll do the second one. No sweat. Okay. And the light goes out. So there's no leakage there. And this mica doesn't matter about polarity. Very quick. Yeah, very quickly goes out. Very good. And then this bumblebee will be as leaky as you know what. And have a sip of coffee. Play a game of free cell. Then computer chess. It might as well be shorted. It even looks sweaty. Okay. We'll do some other measurements here. Let's check. I'm curious to what these values are. I can look on the schematic, but we can also look here. So it looks like 755. Let's see. 70. Oh, it could be 750. Let's see, 2,000. Yeah, 750. Just have to learn the units on it. 750 picofarad. And on this side, 760. So I suspect they're intended to be the same, and that's the same in picofarad world. This looks like a 50 picofarad. Now, 494. 500 picofarad in a package like that. Huh? That's interesting. Okay, what about the resistances? This is, let's take a look. So, 1, 2, 3. That's 12 times 3, 12,000. And we'll just connect this here. And we can't get a good connect. 13.5. I think I want to go ahead and replace that one. This is 222. So that would be 2200. 26. Okay, we'll be replacing that one. Looks like we're going to just redo this box, aren't we? I hate these heavy leaded 1 watt resistors. Okay, that's 333. Okay, 33,000, and that one is fine. I have to keep it. Not that I like it. I might put a V-shape. Well, yeah, a V-shape. metal film would be okay at 50 kilohertz. There would be no issues as far as inductance of the metal film or anything like that. So I'm looking at 1000 ohms. If I can get a connection. Oh, it's on the, and nothing showing. That's picofarads. I don't know what's going on here. Alright, I got a connection. 1000 ohms, 14,000. Every single resistor in here is, this is a 1 meg ohm. I bet you it won't test either. Move it up to the meg ohm scale. Looks like 1.3. No, one passed. Okay, we have one passing 1 meg ohm resistor. Okay, how about the Knotch Adjust? I'll put this here, put this here. This is supposed to be, I think, a 15 ohm, 15,000 or something. Okay, there's 0. And 14.6. No issues on that. Okay, this one is, we'll do this to the jumper. And alright, we're going to 0, then we're increasing 5,000. Okay, I'll make sure that's 5,000 on the schematic. And last thing is we want to see what that inductance is on this 50 kilohertz, or 5 kilohertz actually, what it is, Knotch. 2.79 millihenries. Okie doke. I'll record that. Every resistor except that 1 meg ohm comes out. Oh yeah. Except for this 1 watt, the one I hate. And the capacitors and the bumblebee, and then the other capacitors go back in, and we'll reattach this. So, pretty easy job here. It's now time to put the main and band spread tuning condensers back on. And they'll attach, this green actually goes to the antenna compensator, which is a separate capacitor. Then this goes to, they all attach on the underside. Lovely situation. So, with this facing front, then the back blue attaches here, the middle blue there, the oscillator blue here, and these two isolated grounds from RF attach here. And then we have shielding leads that will attach to the sides. So we'll start, because this is not a factory, there'll be a little bit more length to these leads because it's just, you know, I don't have the ability to do what they do. So anyway, but it won't make any difference in terms of performance. So let me get these leads dressed up here, and we'll attach it, and then I'll show you how it's rolled over and then finished up. Okay, so before we put this in. I took out these wires because it's discolored from smoking. I'll put new wires in there. And we're just going to, this particular capacitor from the oscillator to ground, don't want that one to be leaky, but I'm sure it's not. And there you are, it's not. But it's worthwhile testing it while you have it out. And so while nothing is connected is the time to check for shorts and things of that sort. Picofarad, we'll put it on the nanofarad scale. And we'll just run it through its paces here. Zero, 410. That's pretty much what they always are. 410 to 0. And if you look at that British Telecom book that I've talked about in the past on super heterodyne radios and how they use variable capacitors to resonate the oscillator and so forth at different frequencies. Since you're starting out with band 1 in the broadcast band, that pretty much dictates what you're going to have in terms of response, and I don't see any. That's digital, it's not analog, but there's no shorts. Now the band spread is going to be much smaller. It looks like 25 at the max. 0. Yes, I've had bad capacitors that I've put in, or I had to fix them. Especially when I used a heat gun on one to dry it one time and melted the stator off of the frame. And then I learned that how hot heat guns are. Okay, yeah, that passes all tests. So I'm going to reattach the band spread to the main tuning, which there always are, here on this side, and then we'll go through the wiring and the installation. Okay, so I've got this attached now, but we need to test it. And basically I rotated it around and then put these screws in. Looks like I've not finished the job here. That one's out of whack. Okay. This one's a little bit out of whack. Alright, so for this one, okay, if you do it from here to here, you're not going to get anything. Alright, that's interesting. Oh, okay, that's what it was. This capacitor actually adds so much that you don't get the pure 400. Don't we love to jam that in there? Okay, so that's working. Now this one has no connection to there. This one has a connection to the foil. Or it did. Not this foil. Very strange. To this foil. Right. Huh. Very interesting. Okay. Things come together inside. Alright, that's working. Okay. And then this one has connection to ground. I mean, has capacitance with respect to chassis ground. And that one's working. Then we'll see how different it is when it's all wired up, all the foil is wired up. So we have a foil here, we have the one here, one here, one here. This goes over to the compensator unit, this goes to the compensator unit. And this has a connection to a place. I have to go find it. So I'm going to clean these dirty foil contacts up a little bit and then use solder wick to get them connected. So basically 2 screws here, 2 screws there, 2 here. You just bring it back down once the connections are made on the underside. There's one here, here, and here on the underside, and then an isolated ground on the underside. And that's how it goes back together. It's quite a little operation to get done. Well, there it is with all the furniture reassembled on top. I'll probably torque, these are not torqued yet and so forth. The next step is not to string the dial, and keep on going, but to actually do a lot of testing. In fact, I want to check that redone schematic that David gave me against it, and I want to just go through it, schematic and DC resistance checking, and just go through solder points and all this kind of stuff before we go to proceed any further. And if that passes, then we can get this, the rest of this, these controls and so forth, and put the front face on even, and then start the startup testing. So this is the as assembled cold testing that we have coming up right now, and going to take the rest of the afternoon off and continue with this a little bit tomorrow. Okay, well, I have gone through David's schematics, and basically I found problems with my wiring diagram, not with the schematic. A few interesting things about it is that he does a good detail, but for example, on the schematic, these 2 points are reversed. So it makes no difference electronically. And Hallicrafters just loves to make a maypole out of this particular pin and pile on leads and components and everything else like that. And the result is, a big wad of solder. I just hate it. So I did split that up. But from a standpoint, if you're making 1,000 units, it sure is a lot easier to wire everything to here rather than crisscross and wiring all those things to here. And there's 1 or 2 others like that in here where they reversed the actual wiring in the set is reversed from the schematic, but electrically, up here is one of them. Electrically, there's no difference. So, one of the mistakes was this particular resistor is supposed to be 3,300, and I put in a 33,000. Now, what's 30,000 ohms between friends? And I'm sure nobody's ever done that problem before, but I have to check, and thank goodness I did. putting that in, I did measure this resistor and found out it was 80 ohms instead of 56. Which reminds me, I found basically, let's see, 1, 2, I think there was one other difference I've forgotten now between Mark 1 and the Mark 1BAs and all the remaining runs, and that is, this is 56 ohms and that's 200 ohms, and it's 270 and 500 ohms in all the other sets. Here is, I've got it open, 1.5 megohm. I may put that in. It will clip the noise limiters a little bit. And maybe that's a good idea in today's environment. There are not very many cars driving around with point ignition systems and things like that, which are big noise generators. On the other hand, switching power supplies are everywhere, and you don't know whether that would help or hurt that one. But anyway, I'm going to experiment with that sometime. I found a bad wire over here, which just the insulation was worn off and I replaced it, and then I took some slack out here. Been through everything against the schematic. I could not verify his schematic on the 50 kilohertz mixer. Yeah, it's the second IF mixer box on the other side because I've already buttoned it up. I may go through the notch filter against the schematic too. I think I probably will before I completely say it's ready for cold testing. So, and I've been through all of the connections and checked them out and gave them a good like this to make sure there's no cold solder. So I think it's solid. It's ready for voltage testing, but we'll do the resistance testing later this week, and that will be it. It's ready, pretty much ready to go. Haven't strung the dials or put the dials in yet. That's a little bit down the road. So thanks for watching, and this is Albert, and just be safe out there.